My research is primarily about micromechanics of wood-based composites. So we find out how composites interact with each other, how adhesives interact with wood composites. So normally mechanical testing is done with a full-scale product like a wood beam. However, there's a lot of mechanics behind that happen at a very small scale. So at the cellular level, you need cameras to help you look at that deformation and learn what's happening at that small scale. This is a dynamic testing machine. It can do fatigue tests of materials, and you can do hundreds of thousands of cycles to test how things react under cyclic loading. And I look at small scale deformations of wood cells and adhesive bond lines in wood products.
Okay, great. Okay, hi, I'm a student at OSU. I'm a master's student with Eric Hansen, and my project is on innovation in the forest products industry. Recently, I spoke with Ari, another professor here, and I got an extra project, which is using the DIC, with digital image correlation, compared to your strain gauge. The cameras can image and track the movement of dots. So what we'll do with the wall is we'll paint it completely black and then spray paint it white with speckled white dots on here. And then the camera will track the movement of that speckle pattern as it undergoes load. We will simultaneously take strain gauge data and compare the two results that we get to see how close they compare to each other. You typically have two different types of materials that you use for sheathing in your wall. And the problem, or the theorized problem with the strain gauge, is that your small strain gauge can be placed only on one strand in your OSB, and that data won't necessarily be representative of the entire panel, because this flake could potentially move differently than the entire panel would move. And the use of the DIC images the entire surface of the thing, so we'll probably get better results in the end.
Sure. All right, well, good afternoon. Welcome to the Mechanical Testing Laboratory here at Oregon State University's Department of Wood Science and Engineering. My name is Adam Scouse. I'm a graduate research assistant here. And what I'm doing today is trying to track the bending properties in wood and how they change when wood is exposed to brown rot. And so what I've been doing over the past couple of weeks is creating these environmental chambers, which are really just plastic bags. And inside the plastic bags, I've got some pieces of wood, my samples. Inside there's also some vermiculite, which I've added water to. And I've created an environment which is conducive for brown rot decay fungus to grow. And so these samples are going to sit in these bags for 8 weeks. And what I do is periodically, every 2 weeks, I come into the lab and I test them in a 3-point bending test. And the idea is to kind of track the overall strength and stiffness of these pieces of wood as they're being decomposed by brown rot. I've done some other durability and decay testing, more focused on molds, using a mold box. And I've been trying to create a preservative that's made out of cinnamon oil and juniper oil. But this is all part of an overall durability test on hybrid poplar, a tree that grows here in Oregon that we grow on plantations. Traditionally, it's been used to sell to the biofuel industry, but well, we're looking for other ways to utilize the wood.
Okay. Hi, my name's Jesse Paris, and I am a PhD student here in the Wood Science and Engineering program. I work for Dr. Fred Kamke, and my research is kind of following up what I did for my master's research, which was with wood-based composites. Wood-based composites are when you take wood particles that have been broken down and then reform them into a new structural engineered material through the use of an adhesive binder to glue those two different substrates together. At an anatomical micro scale level, wood is extremely porous and actually resembles much like a sponge, but you see it's absolutely full of pores. When that adhesive, when that liquid binder that we use to hold these composites together cures, the penetration pattern, how that flows into the adhesive sponge, influences that bond strength. However, I use 3D X-ray tomography, which is the same thing as a medical CAT scan. And so quite a bit of my research has actually been focused on the chemistry side of things and trying to prepare wood adhesives that have a heavier element inside of them that allow them to be visualized with an X-ray technique.